agreed that we want to look at shorter wavelengths with smaller telescopes. Let me tell you about some bigger telescopes that are looking at longer wavelengths. So Gwen asked me to do this, so I said I would do it. So, now, I'm just going to quickly, Roman is a survey telescope to really study dark energy and do exoplanet demographics. We know that. Here's the basics. I'm going to go really fast because I know we want to have discussion at the end, so I'm sorry. It's HST sized with an enormous field of view, right? That's it. And there are some applications that I wanted us to think about aside from the sort of basic core surveys of Roman. And that's why I wanted to bring this up. And I think I put something in a chat the other day about this. Here's the filters. We also, there's these filters going down to, 5,000 angstroms, but now we also go out to the K-band. We just added a K-band filter in case you didn't know that, which is kind of interesting. We've been pushing that for a long time for Roman. It's an infrared telescope after all. So we now have a K-band filter. We're pretty excited about that. And there's a GRISM and a PRISM. And I think the GRISM is the thing I wanted to sort of tell people about. So here's a picture of the field of view of Roman compared to HST on the bottom and Webb. The GRISM, as I've highlighted in red on the right, goes from about 1 to 2 microns at R600. So it's a fairly limited wavelength coverage, but and spectral resolution, but interesting nonetheless for the GRISM. And it's slitless, so you get the entire area all the time. So that's interesting. It makes life complicated when you're deblending objects, but I think there's some interesting science that can be done along the lines of the things that we've been talking about. So here's the core surveys: microlensing survey, a supernova survey, and a high latitude survey for imaging and spectroscopy. So that's 2,000 square degrees. This is just the layout over the nominal lifetime of the mission. You don't need to understand anything about this plot. It's just a DRM of the mission that shows that also that about 25% of the time for Roman is going to be geo time. So that's something to think about too. There's these big core surveys which dominate the time of the nominal 5-year mission of Roman, but about 25% of the time will be for geo projects. And I'm nominally talking about Roman here, but we should also remember that Euclid is going to fly, and it's going to probably fly before Roman, of course. The pixel scale is a little coarser. The field of view is bigger. The survey area will be a lot bigger, and it also has a GRISM. It's a little bit lower spectral resolution. You can see here it's about 380. The GRISM is about 600 in the middle, and the wavelength coverage is slightly less. But in other words, we're going to get 2 big surveys with GRISM spectroscopy in the rest frame near infrared coming in the next 5 years, let's say 5 to 6 years. So we'll have a lot of these sort of demographics of spectroscopically detected objects from core surveys plus geo mode for Roman anyway. So for us, I think that's interesting, and this is what I wanted to talk about and think about. So I'm almost done with my quick Roman. And the reason I'm going quickly is because you can find a lot of this material on the web if you so desire. I mean, Roman will be launched right after JWST. It's next in line. So 2025, 2026, it'll go. There's a wide area survey. So, think about 3D HST GRISM survey over a huge area at a higher spectral resolution. So that's about 600. It's not going to go as deep for the high latitude survey, of course, but there's a geo mode too. We can go a lot deeper, and the area is enormous. The spatial resolution is high because it's HST-like, right? So it's 1/10 of an arc second. So I think, for doing things like finding large unbiased samples of galaxies that are experiencing outflows and feedback, this will be relatively simple to find sources that are shock excited over large areas of the sky. And that'll give us, at high spatial resolution, to look at things to directly compare to some of our high resolution models that we've been talking about, like fire. So we'll have good separation spatially from things which are star forming and shock excited gas, at 1/10 of an arc second resolution. And of course, the demographics for Roman is the whole name of the game. And so it's understanding where feedback and outflows are happening as a function of galactic environment. So it's a little bit different than the things we've been talking about. We've been talking about atmospheres of galaxies and CGM, but I always am trying to pull us back to start linking up the ISM to the CGM. and the power sources in the galaxies, because I used to study outflows. And that's where the material is coming from. So these sort of large area surveys, I think, are interesting for me to sort of take the sort of 3D HST to the next level. And I think that's going to drop out of both Euclid and Roman, and we should be prepared to sort of take advantage of that, even from the large area surveys, but if also not from a geo mode as well. I think that's all I wanted to say about Roman.